Welcome back to the instructional video series on hierarchy of energy theory, where we unify all physics under one big, beautiful physical model. I am your theory influencer, Scott Gordon. In this segment, we reveal the ingredients to make a photon, begin to peel back the photon's inner structure, and show why the photon's energy does not disperse into the space-time energy medium. We then independently derive the energy equation for light. Certainly, this is worthy of a second Nobel Prize. And once again, if you don't think so, not to worry. More fantastic opportunities are coming as hierarchy of energy theory is advanced. You can be a doubting Thomas or jump on board. Perhaps you can use hierarchy of energy theory to advance your own research and earn a Nobel Prize. The choice is yours. It should be obvious by now that light is not a wave of energy within the space-time lattice of building blocks. Light is a packet of energy that is locked into a wave-like structure. But what is this structure? And how does this structure provide the means to lock in energy? Well, I'll tell you. In lesson 5, we found that a wave in space-time occurs when the energy existing within the space-time lattice oscillates the building blocks of space-time. While this energy wave in space-time moves at the speed of light, it is not a light wave. So how do we construct a photon particle that is also a light wave? Great question. And hierarchy of energy theory gives a great answer. Recall that hierarchy of energy theory is the ultimate reductionist approach, where the building block of space-time is used to create everything in the universe. Let's consider what would happen if we not just moved the space-time building block, but we accelerated it to the speed of light. In essence, we would be accelerating a quantum unit of space-time, because a building block represents a quantum distance, a quantum time unit, and its associated energy along the quantum distance of space-time. To accelerate a building block, we add energy to the building block. This energy and the building block are both accelerated to the speed of light. And that's when the magic begins. Once a building block has reached the speed of light, it transitions into a photon. But what is exactly happening in this process? Let's recall from lesson 3 that energy can only be added to a building block on its plane of spin, which we will now call the energy plane. Accelerating a building block to the speed of light can only be achieved along a direction on the building block's energy plane. The energy added to the building block becomes associated with the building block. But if the building block does not reach the speed of light, it will fall back into a position in the space-time lattice, and its added energy will disperse back into space-time. So the question is, once a photon is moving at the speed of light, can it revert back into being a building block of space-time? And the answer is no. But why? Well, I'll tell you why. Because for a photon to slow down, it would have to lose some of its energy into the space-time energy medium. But where would the photon lose that energy from? We can immediately rule out energy escaping from the axial direction of the building block, because there is no energy along the axial direction of a building block. That leaves only two other possibilities: escaping from the two independent energy directions on the building block's energy plane. But when the building block reaches the speed of light, all the energy added to the building block must exist along the direction of its motion. No energy can be aligned along the independent energy direction on the building block's energy plane, because that would mean the building block would be moving faster than the speed of light, and that can't happen. If energy cannot exist along the axial direction or along the other independent energy direction on the energy plane, then the only other direction the photon could possibly lose energy from is along the direction of motion. And this can't happen either, and we will show why when we show how a photon's energy wave is created. If energy can't leave the photon, then it can't revert back to a building block, and it is destined to move at the speed of light in space-time forever. We need to emphasize that the photon is no longer a building block existing in space-time. It is something else. It is now a particle that coexists in space-time. And this particle, along with its energy, is independent or outside of the lattice or fabric of space-time. The photon's energy is locked in and moves as one structural entity through the space-time energy medium at the speed of light. In addition, a photon's energy is not the same as the energy associated with space-time's building blocks. These energies are independent of each other. And this distance is also expressed in mathematical terms, which we will discuss later in this lesson. Now that we know how a photon must move forever at the speed of light through the space-time energy medium, how does a light wave fit into all this? A photon is created by accelerating a space-time building block to the speed of light. This acceleration sets up a chain reaction in the building blocks of space-time, where space-time building blocks are accelerated in the region in front of the future photon, pushing them closer together. This chain reaction of compression moves at the speed of light ahead of the future photon as the future photon is being accelerated. Once the photon itself reaches the speed of light, the center of the photon and the leading edge of the chain reaction are both moving at the speed of light. The distance between the photon center point and the leading edge of the chain reaction becomes a fixed distance. And this is how the energy of the photon is locked within a fixed distance, where this leading half of the distance contains half the energy used to accelerate the photon. The trailing region of the photon locks in the other half of the photon's energy. In this case, the space-time building blocks were stretched apart on the trailing side of the photon and are moving back to their original position after being displaced forward when the leading half of the wave passed through. The leading distance and the trailing distance locks in all the energy used to accelerate the photon, completing the photon's entire wavelength. Since space-time is left exactly the way it was prior to the photon moving through it, there is no energy lost along the direction of the photon's motion. The mathematics of the resulting photon wave created in spacetime is still represented by the longitudinal wave equation presented in Lesson 5. The wavelength of the longitudinal wave contains all the energy used to accelerate the precursor building block to the speed of light. But does this make sense? Of course it does. It requires more energy for the building block to be accelerated faster. The quicker the building block reaches the speed of light, the shorter the distance that the leading edge moves before the photon's center point also reaches the speed of light. That means a shorter wavelength. And obviously, the opposite is true. When the acceleration is slower, the energy required is less and the wavelength is longer. Now here's a question. We said that spacetime is displaced forward in the leading half of the photon. But what is the maximum displacement of spacetime that occurs at the photon's center point? The maximum displacement is one quantum distance, because the building block itself represents a quantum unit moving at the speed of light, and it has no chance of reinserting itself within the underlying space-time lattice. So again, the photon will move in space-time at the speed of light forever. Since all photons are composed of a space-time building block accelerated to c, all photons contain a displacement of space-time by one quantum distance. Here's another question. How much energy is contained in a photon? Let's have some fun and answer this question by using only this model to independently derive the known equation for the energy of a photon. Oh, and by the way, hierarchy of energy theory does not change what we already know about physics. It just gives us a complete physical model to understand the physics and mathematics we already know. Let's start with a line of space-time building blocks and consider a 2 quantum distance segment on the line. We now move the middle building block 50% of a quantum distance to the left, thereby compressing the first quantum distance by 50%. This would also stretch the second quantum distance by 50%. The movement of this building block requires energy, and the energy added would be equivalent to adding 2 more quantum distances. This would double the energy within the section of the line. When we displace the middle building block, we basically halved all the quantum distances in this segment when compared to the original segment. So halving the quantum distances along the segment correlated to doubling the energy along that segment. Because the speed of light is defined as a quantum distance per quantum time unit and always equals 1, this also means that halving the quantum time unit along the segment also doubles the energy along the segment. This inverse type of relationship that exists between the energy and the quantum time unit provides the means to create a very useful relative constant. Since multiplying the energy contained along a quantum distance by the relative quantum time unit results in a constant. Can you guess what this relative constant is? Oh yes, it's Planck's constant. So let's go back to our building block line segment that created the 2 additional building blocks by the displacement of a building block. To find the energy along this segment, all we need to do is divide Planck's constant by the number of quantum time units, which is the same number of quantum distances in the segment. But if we let the added energy distribute across a larger segment, let's say 8 quantum distances, or 8 quantum time units, then the energy would be Planck's constant divided by 8. The larger the segment we distribute the 2 added quantum distances along, the less the energy required for the 2 quantum units to be added into the line. To better visualize this, we can see what happens when a spring is displaced at its center point. Let's move the center point of a 10-meter spring by 1 centimeter where the spring represents spacetime. The displacement of the center point represents the addition of the extra quantum distances. If we do the same for a 20-meter spring and displace its center point by the same 1 centimeter, it takes half the energy to displace the center point 1 centimeter in the 20-meter spring. Now let's look at a photon. To determine the amount of energy that exists in the photon segment, or its wavelength, all we need to do is divide Planck's constant by the total number of quantum units. But we don't know how much time is in a quantum unit, nor do we know how many quantum units exist along the wavelength. Fortunately, we don't need to know. All we need to know is the total time. To find the energy of a photon, all we need to do is divide Planck's constant by the total time, which is the same as multiplying it by the wave's frequency. And there you have it. The energy of a photon equals Planck's constant times the frequency. We can also arrive at the equivalent answer by dividing Planck's constant by the wavelength. But when we do that, we have to use the conversion factor of 1 quantum distance per 1 quantum time unit, which is the speed of light. So, alternatively, we can write this equation as the energy of light equals Planck's constant divided by the wavelength times c to the first power. So the energy of light is expressed mathematically using c to the first power. But wait, there's more. We have already mentioned that the energy of spacetime and the energy of a photon are different. If you recall from our earlier lessons, we defined a dimension as the independent alignment of energy. Spacetime has 3 dimensions because there are 3 independent energy directions. But in the case of a photon, the photon's energy itself is independent from the energy of spacetime. And therefore, according to our definition of a dimension, a photon's energy exists as another dimension. But what makes these energies different? After all, they are both waves of energy moving in spacetime at the speed of light. Well, here's the difference. A wave of spacetime is a wave of energy moving through the energy medium at the speed of light within the lattice of building blocks, dissipating as it does so. The wave of a photon is a wave in spacetime created by an energy associated with a building block which was accelerated to the speed of light. To see the difference in mathematical terms, we should remember that spacetime should not be looked upon as an array of meter sticks and time clocks. We need to look at spacetime as an energy medium that varies its energy density. In this sense, moving spacetime is not something we can acknowledge in terms of distance and time. Spacetime, whether it's moving or not, is always looked upon as an energy medium where we can never determine its energy density. That means that there is no concept of spacetime moving in a distance and a time unit. There is just the ratio of the quantum distance and quantum time unit that always remains at the constant value of 1, even as the energy density in spacetime changes. Once we realize that the parameters of distance and time do not play a role in motion within the spacetime energy medium, then all we have left to express a wave in spacetime moving at the speed of light is the ratio of 1 quantum distance per 1 quantum time unit, but without the terms for distance and time. In mathematical terms, we can express this as the quantum distance raised to the 0 power over the quantum time unit, also raised to the 0 power. This ratio is 1 over 1. Or alternatively, we can express this as the speed of light raised to the 0 power, which is 1. Therefore, we can write the energy of spacetime as equal to m to the sub 0 times c raised to the 0 power, where m to the sub 0 is just the change of energy in spacetime caused by the motion of energy in the spacetime energy medium. I would also like to point out that the energy wave of spacetime is not quantized. These waves are not associated with the building block accelerated to the speed of light, where quantum distances are created to displace spacetime. Planck's constant is a relative constant, and it is useful in finding the energy distributed over spacetime by particles containing energy of a higher energy tier. Therefore, the building block accelerated to the speed of light forms the basis of the quantization of particles in spacetime. This is why the particles in spacetime are quantized, while spacetime exists as a smooth, continuous energy medium. This foundational structure of our universe is what's missing in our current understanding. We have the math, but we don't have the underlying physical model. And here's the fun part when looking at the equations of our two energy tiers. It doesn't matter how much energy is present in our underlying spacetime. Its energy is always expressed mathematically using the term c to the 0 power. Therefore, any light moving in any region of spacetime, no matter what the energy level is, will always move through it as c to the first power, the speed of light. Again, the speed of light is the same in all inertial reference frames. In summary, a photon is created when a building block of spacetime is accelerated to the speed of light. The locking of energy into a photon is accomplished by the photon moving at the speed of light. Once the photon reaches the speed of light, it will never slow down or lose its energy into the spacetime energy medium, and it will move at the speed of light in spacetime forever. Planck's constant is a relative constant created by multiplying the energy along a quantum distance by the relative quantum time unit. Planck's constant forms the basis of quantum mechanics and provides an easy means to determine the energy of a photon. The base energy tier is the energy of spacetime and is expressed using c to the 0 power. The first energy tier is the energy tier of light, and it is expressed using c to the first power. Energy tiers are why we call this theory hierarchy of energy theory. And you will be even more amazed when we get to the next higher energy tier. Yep, you guessed it. It's E equals mc squared. But first, we need to deal with more immediate mysteries concerning our photons, such as light is an electromagnetic wave. So how do photons generate their electric and magnetic fields? That is the topic of our next Nobel Prize winning lesson. If you are curious about this novel approach to find the theory of everything, then click the like button below and subscribe to this channel so that you can be notified when future lessons are released.